All right, the second part of the LID methodology is to identify. In the identify step, the goal is broken into two parts. First, we want to identify the remaining unlabeled tables and label the denormalization type. And then we want to identify the key fields for both the primary and supporting entities only. So let's start with the first part, identifying the remaining table types. Now remember this, because it's important. The real-time customer profile always defines a person, their traits, and/or their associated behaviors with the brand or company. A primary entity of the profile is the core of the real-time customer profile, and it's always composed of two classes, XDM individual profile and XDM experience event. Dimensional entity data is used to provide additional context to either a trait or a behavior of a person. Any data that exists outside either of these two entities must be denormalized back into their parent tables. If you haven't noticed by now, this is an important concept, and I will continue to bring this up over and over again as we work through the LID methodology. So how do we identify the remaining table types? Well, there are a few basic steps that you can perform. One, start with one of your pre-labeled tables. We call this the parent table. Then, read the relationship from the parent table to the related table that remains unlabeled. Cardinality should be written on the related table as follows. Label with a D any one-to-many or many-to-one relationship, and label with a B any bridge tables. Remember, those are many-to-many relationships. For example, let's start with student and student certification tables that you can see in this diagram. Reading the relationship from the parent, or the student, to the related table, student certification, it reads, as one student record can be related to many student certification records. This is then a one-to-many relationship and should therefore be labeled with a D. Next, let's look at the student and student enrollment tables. Notice that the student enrollment table has another table that is related to it, and that both the relationships coming into the student enrollment table are many-sided relationships, typically denoted with in an ERD diagram using this symbol. When you encounter a table with two many-sided relationships joined to it, this is considered a bridge table. This means you can immediately label this with a B, signifying it is a bridge table. And then this also triggers the first rule of bridge tables. Bridge table rule number 1 states simply, when you encounter a bridge table directly related to either a P or an E, the many to one side of that bridge acts like a lookup table. Otherwise, you would follow the normal standard denormalization rules. Interesting, we just found a lookup table. So following this rule, the other side here would be labeled as an L. Let's try this now by looking at the demo data model. You'll notice that many of the tables remain unlabeled. In fact, there's about 5 sections. Identify these tables and note the parent table that they are each related to. Let's start by focusing on the tables that are related to the individual profile table, customer. The first thing you should notice is that the customer location table has two many-sided relationships coming into it. This means this table is a bridge table and therefore can be labeled immediately with a B. This then immediately triggers bridge table rule number 1, which states that when a bridge table is related to either a P or an E, that many-to-one relationship acts like a lookup, and therefore the location table is labeled with an L. Simple enough. Next, let's focus on the unrelated tables related to the experience event. Conveniently, everything is already labeled inside of our diagram, and so you can just move on. Next, let's work on the unlabeled tables related to the lookup tables. You'll see there's 2 areas to focus on within the diagram, so let's pick one to start with, and in this case, I'll choose product. Looking at the relationships between the product table, the parent, and the product brand table, the unlabeled one, the relationship reads like so. One product record can be related to one product brand record. Therefore, the product brand table is labeled with a D, as it follows the one-to-many or many-to-one labeling rule. Next, let's look at the product and product category table. You should immediately notice that the product category table has 2 many-sided relationships coming into it, and therefore it can be labeled with a B, as it's a bridge table. Bridge table rule number 1 kicks in immediately and states that the many-to-one side of the bridge table relationship will be an L when it's directly related to either a P or an E. But in this case, the bridge table is not related to either a P or an E. So we would follow the standard denormalization rules. Therefore, since the relationship still reads as a many-to-one from the bridge table, the other side would be labeled as a D. Jumping over to the other lookup table, you'll notice two tables with relationships read both as one-to-many, store-to-store addresses, and many-to-one, store-to-store type. Therefore, follow the standard denormalization rules, and both tables are labeled with Ds. Simple enough. The final diagram now appears with every table having a label, whether it's a P for a profile, E for an event, L for a lookup, or a D or a B signifying that we'll have to do something with those during the denormalization step inlet.